So,
Recording is on.
yeah, now recording is working fine now. So, first of all, I welcome you all, and I want to set rules for this program who are actually new, who are already old, who understand this. But still, it's always better to fix up the rules in the beginning itself. So, first rule is always sit in a quiet and non-distracting place. So, my request is that you should be sitting away from any kind of noise or the place where you can be distracted. So, make sure that you sit in a quiet place. Second is you should always be taking notes. So you may call me old school, but the notes are important because notes are something which you can recall. You can recall at later date, at later time, whenever you feel so. So always make sure that you take notes because every mind has got a different way of functionality. So you may take notes in a different way. Other person can take notes in a different way because that is the way how the mind works. So make sure that you take notes. You should be asking questions. So any kind of the questions that you ask is not a problem. You should be asking questions. Feel that you are here to learn. So everyone is interested to. I request everyone to just mute their audios because some echo is coming up. So it's requested that everyone should be asking questions. Any kind of the queries that you have, any kind of the problems that you have, you should be joining. You should be asking those questions. Don't feel like that it's a trivial question, it's a silly question. Any kind of the question is an important question because that is going to make a difference in your knowledge about that particular topic.
Good morning, sir.
Good morning, good morning. Please continue. And keep your mobiles on silent. So you see everyone is having your mobile. I understand there is a time that people keep on calling you, so it's always good that keep your mobile on silent. So I request everyone to pick up your mobile. I'm also going to do it on my own, and I'm going to make it on a silent basis. So I request that everyone should be keeping their mobiles on silent because that's very important, and so that there is no distraction on the mobile for this. There should not be any crosstalks. So all of you are requested not to discuss anything in between. It's always better that when but one person is asking a question, he should be listened properly, and the trainer should be answering that question. And in case there is some query, then you can ask, but don't go for any crosstalks in between. That is
Good
actually delays the matter.
morning, but sir.
Sir, we are already through with the training, sir. Please put on the mute. Then complete your assignment. So all of the assignments that are given to you, please complete. Now we are also actually testing one online portal where actually you can put in your answers to your assignment directly, and you will also be given certificate because few of the candidates have asked for the training certificates. So we are working on that. By next week you will be having one online portal ready where you will be actually able to see. Pardon? Any questions?
नहीं सर, अभी तक तो कोई नहीं आया.
क्या नहीं आया? Can you please keep your audio on mute, please?
भी नहीं है, अंकुश भी नहीं है.
Sir, the training is continuing. Can you please keep yourself on mute, please? Okay. Sorry, I request everyone to keep your audio on mute because that is causing problem with a lot of other people.
नजीम टाइम पे आया करो भाई, 8:15 का टाइम है.
Just a minute. I think there is another meeting which has been actually logged on over here. Sorry, it was my bad actually. There was another meeting which I had already logged on and the people were actually speaking over there. So sorry. So now the rules are set, and I hope it's clear to everyone. And we have also put in one more messaging platform over here for direct messaging. Although you must be getting your emails where the reminder of the training program is going on, you will be getting that emails on a regular basis. Like it gets almost a day before, and then it also goes for 1 hour before, and maybe at this point of time. So they keep on coming, and we also have our own messenger system where I'll be sharing the link for that, so that all of you people actually understand that all kind of messaging that has to be done to you, any kind of recordings that need to be sent, that is also available there in the channel itself. So you can follow that. I will come to that in the end of the program. So not to delay any matters further, I'm now requesting our Mr. Vipin to actually start with the training. And just to give a brief on with Mr. Vipin, he is having 35 plus years of experience in instrumentation industry only, and he has been a part of a lot of big companies in the selection, in the design, in the implementation, and in the maintenance services for the complete instrumentation for 35 years. He has worked in India. He has worked for Gulf countries. He has worked for very big MNCs also. So he has got a diverse experience, and he is going to share the experience what he has learned in last 35 years with all of you people. So over to Vipin ji.
Thank you, Mr. Bhatti. Yeah, thank you. I hope you are able to see the slides.
Yes, sir.
Okay, good. Fine. Good morning to you all, actually. Okay. And welcome to this flow training session, part 2. What I have done is I have directly gone to the slide because the previous journal slides were same, which we shared in the last meeting. So I will not be repeating that. So because there are so many flow instruments are there. Some of them we covered in the last presentation, and the balance we will be covering in this presentation. Now, before we start, the question which most of the engineers they ask, actually, there are so many flow instruments. So how do we decide which flow instrument we should opt for a particular service? And my answer has always been there are 3 important things which we need to look into. First thing is, what is the principle of the operation of that instrument? Then what are the advantages associated with it, and what are the disadvantages? So unless an instrumentation engineer is familiar with these things as a minimum, he cannot select and design right flow instrument for his or her application. So in today's presentation, I am going to discuss about some of the flow instruments and talk about their positive pros and cons, advantages and limitations, so that you guys have a fair amount of understanding, okay, about uh, where to use which instrument. So the first in this line is we will start with turbine meters. Now turbine meters basically historically they have been quite old. They have been used for a very long time actually. Okay. Now as you can see in the diagram, the direction of the flow, the arrow. So the fluid is coming in this direction, and then you can see the orange one, which are the impellers on the shaft. So when the flow is there, the impellers start rotating actually. Okay. So that is the principle. It is purely a mechanical. Okay. So the moment, the moment the impeller starts rotating, so you have like revolutions per minute (RPM). Okay, and these are basically the pulses which are picked up. So, so that is the basic, in very general and simple way, the principle of turbine meter. Now let's look at the advantages. Having said that, let's look at the advantages. No external power supply, because the power to move the impeller comes from the fluid itself, whose flow you are going to measure. Okay. Second thing is, turbine flow meters are suitable for cryogenic liquid. Now, what is cryogenic? Cryogenic is liquids we are talking about in minus, below 0 degree. So minus 20, minus 40, minus 100, anything which is minus basically is a cryogenic liquid. So these meters are suitable for that particular application. Then the other advantage of this is they can be used for extremely high temperature and pressure. So you can select the impeller and the shaft material which can withstand those high temperature and pressure, and you can design a turbine meter based on that. Now, if you look at the limitation, there is a limited choice of material. So it is not that for every application you might get the material suitable for that particular application. So that is one of the main disadvantages of turbine meter. The second thing is they are used only for low viscosities. Viscous means thick. So for very thick liquid, turbine meters are not suitable because then the blades will have a problem in moving. They will get stick on the impeller. So all sort of issues will come. Now, any moving instrument always have inherent disadvantage of wear and tear. So movement means wear and tear will be there. So that is another disadvantage. Sensitive to contamination. So if any liquid has some solid content, it will contaminate the impeller and the shaft will get stick onto that or may get stuck up, inside the blades. Now, these are flow sensitive flow profile, which means we need to give some upstream and downstream length proper so that when the fluid velocity, the fluid which goes into the turbine meter has a very laminar flow, has a very smooth flow. Okay, there should not be any turbulence. So that is required actually. That is one of the requirement when you are using a turbine meter. Okay. Then, if suddenly there is a fluctuation in the flow or there is a change in the differential in the inlet pressure, that might cause some damage or error, okay, in the reading of turbine flow meters. So these are some of the advantages and the disadvantages which I have shared in with respect to the turbine meters. These are very simple and straightforward, but still if any question is there, please feel free to ask. Coming on to the second type of flow meter, one of the very simplest type of flow meters available, they are called as rotometers. They are generally installed in the vertical line and they have a float basically which moves up and down depending on the flow rate. So it's very simple. I mean, there is no other phenomenon in this actually. A simple float is there, and with the variation in the flow, the float will move up and down. If the flow is high, the float will be up. If the flow is less, the float will come down. Now, if you look at the advantages, it is inexpensive. It does not require any external power supply because purely it is a mechanical meter. You can measure any liquid, gas, or steam. There are no inlet outlet straight length required. It's very easy to install. You can also couple this with a transmitter to get 420 milliampere. Generally, these are like flow gauges, you can say, like level gauge. These are basically flow gauges, but you have some option wherein you can also fit a transmitter along with the rotometer and get 420 milliampere in case if you want that signal. Okay. The limitation is they have to be installed in a vertical line only. You cannot install this in the vertical line, horizontal line, sorry. And these are affected by the density, temperature, and viscosity. So if there is a change in the density or the temperature or the viscosity, then there will be an error in the reading. Now the question comes, why so? Because when you design the float is actually the measuring part. The float in the rotometer is actually the key thing. So that float is basically designed based on the density of the fluid you define in your specification. So if the density itself changes, then obviously whatever the flow you are seeing will not be an accurate flow. It will be an erroneous flow. So it is density sensitive. And obviously temperature variation will cause a change in the density. And likewise, viscosity will also have a same effect. Okay. Then the other thing is whatever the liquid you are measuring, for example, it should be pure clean one. It should not have any contamination because that contamination might stuck up the float. So if the float gets stuck up, then it will not move and we will not be able to see the reading or the flow rate. Is it clear? I mean, it's very simple, straightforward. But still, if anybody has any question, you may ask.
I think Jaspreet has got some question. He can ask.
Yeah, please.
So what kind of liquid? Can you specify the name of any example as per your experience, what we can measure from here?
No, you can either tell you can wear any clean liquid. The clean liquid can be water. The clean liquid
Distilled
can
water or
be, yeah, anything, basically, which obviously, if it is little bit of corrosive, I would say, obviously, then you need a metal type, basically. Okay.
Hmm.
If you see that there are two types. One are purely glass type rotometers, and one which has these flanges. Okay, which has a metal body behind and the needle. If you can see the red one. Okay.
Okay.
So yeah, but any clean liquid you can make it. There's no question about it. And the main thing here is generally the flow rate is in 1:10 rangeability. Okay, so when you are
Hmm.
designing it, okay, the flow range, the rotometers will generally come, for example, zero point 0.4 to 4 meter cube, 1 to 10 meter cube. Okay, it's like this. The rangeability of the rotometer generally comes 1:10 actually. Okay, just for your information.
Thank you, sir.
Basically, for rotometer selection, you have got 2-3 things that are to be kept in mind. One is basically the liquid has to be very clean. No suspended solid should be there, and the flow fluctuation should not be very high. It should be very simple, and the turn down ratio can be only 1:10. So you cannot have a very high turn down ratio to be measured with the rotometer. So you can have only 1:10. That is the way, and the liquid has to be very clean. No much of very high pressure fluctuations. So these are the main criteria for this. Plus the MOC of the rotometer is very important based on the liquid that you are going to use.
Noted, sir.
Because
Now
I
moving
see
on.
the
Sorry.
having lot of points in the slide itself, but very few questions coming up.
Yeah, in fact, I am expecting more questions. The more they ask, the good I feel actually. So at least. Okay,
Not
so
a problem,
now.
sir. You can continue. Yeah.
Yeah, okay, so moving on to now another and one of the very important and quite widely used in the world, vortex type of flow meter. Now vortex, there is some very interesting story behind it. I will just take a minute behind this. So if you must have seen that in a pond or a lake or a river, if there is a stone or a rock and the water is hitting on it, and then the water gets bifurcated on the both sides of the rock or the stone, and it produces a swirling motion, a round motion, a curly motion around it. Okay, now that is the basic underlying principle of a vortex meter. So what happens is a shader bar, if you can see in the picture, a shader bar is kept. It is called a bluff body also. Sometimes you might hear the word bluff body. The shader bar, it is one and the same thing. It is a piece of a metal with a specific shape which protrudes which goes inside the pipeline. Okay. So when the fluid hits the shader bar or your bluff body, it gets it moves on both the sides of the body in a swirl motion, a curly motion. So the frequency of these curly motion is picked up. So higher the frequency of these curly motions, the higher the velocity, higher the flow rate. Okay. This is simple in terms of the principle. So you are just putting an obstruction in the line, causing the flow variation. The flow variation basically in the form of the curly motions are picked, the frequency of that, and that gives you a measure of the velocity or indirectly measure of the flow rate. Now, if you look at what are the advantages it offers, there is no moving part because this bluff body shader bar is a solid piece of metal, so it is not moving. It is just inside the pipe like a piece of metal. Very rugged construction. You can measure liquid, gas, and steam from a vortex meter. These are also used in pharmaceutical industries, where sterilization is one of the very important things actually. Okay, is very important parameters you have to take care. It is unaffected by pressure, temperature, and density. So the beauty of this vortex meter is, as you had seen in rotometer, they get affected by density, temperature, and viscosity. Here, it is independent of pressure, temperature, and density. So even if it changes, it will not give you an erroneous reading. It will not have any impact on the reading. And another advantage and the beauty of this meter is a linear relation between flow rate and the measurement. So if the people who attended my last lecture, I already told that there are some meters which have direct relation with the flow rate, and there are some flow meters which have a square root, for example, orifice plate. So the beauty of this meter is it has a direct relation, the flow between the flow rate and the measurement. Now, like any other volumetric instrument which measures volume, flow rate, it requires straight length. So that means we need some section of the upstream pipe which has to be straight and downstream to keep the flow laminar and velocity streamlined. And again, minimum some Reynolds number is required, because to generate those vortices or curly motion, some minimum flow rate is required. So the instrument is not suitable if the flow rate is very, very less, because at very less flow rate, the curly motions produced are very less, and it becomes very difficult for the electronics to pick those movements or the curly motions. So that is another disadvantage basically. For a very less low flow rates, generally this instrument is not suitable. Any questions on this, please?
Yeah, Jasprit has got a question. I think he should be asking.
Yeah.
So what is the maximum size we can go for with vortex, and what is the fluid properties required to get the vortex flow meter installed instead of electromagnetic flow meter?
See, I will answer the question piecemeal. Okay. Now, vortex meters, theoretically, you can have, you can go for a very higher size also in a vortex meter theoretically, but practically, because of the shutter bar and the bluff body, if you go for a very higher size means, let's say about 12 inch, 14 inch, 16 inch and above, then there will be a vibration in this shutter bar. Okay.
Yes, because
So
the
it will
length
start,
will be increased.
yeah, so it will start resonating. And God forbid, if it resonates at the resonant frequency, then fatigue will creep in and it might damage the shutter bar. So that is the thing which limits the size of the vortex meter. Okay. But you can definitely get 6 inch, 8 inch, up to 10 inch also. Okay. Then some vendors give, some vendors limit up to 8 inch, some vendor limit up to 10 inch. It is vendor specific also. So that is question number one, to answer your question on that. Question number two, electromagnetic flow meter, the most important criteria is you need to have a minimum conductivity in microsiemens for the liquid which you are going to measure the flow rate, because the principle is based on that conductivity. Okay.
Correct.
Whereas in the vortex, there is no such thing. As you can see, pressure variation doesn't have any impact, temperature variation doesn't have any effect, density variation doesn't have any effect. And unlike other instruments, because capacitance type instrument is based on the dielectric constant, magnetic type is based on the conductivity principle. So this is not dependent on any parameter, except, as I told you, if you see the limitation, the last point, minimum Reynolds number. So a minimum flow rate, because to produce the vortices, you require a minimum flow rate. Okay. That is the only limitation. So the flow rate is the only limitation. Beyond a certain point, it will not be able to measure it. Otherwise, uh, density, dielectric constant, conductivity, etc., has no role to play in this. I hope I answer your question.
Yes, thank you.
Okay.
There is one more. There is one more question from Nikhil. Is primarily in the chat box for accuracy and rangeability. He wants to know about the accuracy and rangeability for the vortex flow meter.
Rangeability by default, you can easily assume 10:1 as a minimum. Okay. Some vendors might give the higher rangeability also. That's number one. Number two, in terms of accuracy, it is as good as any other pressure transmitter, DP type, or a temperature transmitter, which have a journal nowadays because of the smart type. You get very good accuracy of point. It comes in point like 0.5 or even less than that, basically. So in terms of accuracy, the instruments are quite accurate, as good as any other pressure transmitters or differential pressure transmitter or temperature transmitter, as a matter of fact. Rangeability can go anywhere about 10:1 to 20:1, 30:1. Depends on vendor to vendor size. It has some other factors also to look into actually.
Yeah, Akesh wants to speak, I think.
Yeah.
Hello, good morning, sir.
Yeah. Good morning.
So my first question is, you said the shredder bar might break if we go for high side. My first question is, can we replace the shredder bar in case of any breakdown? And my second question is, can we install in vertical line like we did in Rotometer? And my third question will be regarding its repeatability.
Okay.
Thank you, sir.
So your first question, sorry, is that shader bar can be replaced?
Yes, sir.
Okay. Now, shader bar, if you see here, basically it is actually hermetically sealed. Okay. So if you need to change the shader bar, you can definitely replace it, but the cost of replacing the shader bar is such a high that generally people would prefer to change the complete assembly itself actually, in case if it breaks. Okay. But nevertheless, yes, you can replace the shutter bar. That to answer your question. Yes, you can replace it actually. Okay. But what I told you, this is a rare phenomena. This is not something you encounter, on daily basis, regular basis, because these shutter bars are very of rugged construction. If you see the point number 2 in the advantages, rugged construction means a very solid construction. Okay. So generally, the vendor themselves, they will not recommend if the line size is higher and the velocities are going much higher, where they might start causing the vibration of the shutter bar. Okay. So if that doesn't happen, then obviously the breakage or the fatigue will not happen. So that is your question number 1. Question number 2, whether you can install in a vertical line. Generally, the recommendations from the vendors come to mount it in a horizontal line itself. Okay, the way it is shown in the picture actually. Okay, it is not that you will not measure the flow if you mount in a vertical line, but then you need to see, because anything which you are mounting on a vertical line basically will be like a gravitational force. So it will have, there are many other factors we have to see in, because the shutter bar needs to be perpendicular to the pipe. Okay. Now in a vertical line, because of stresses or something else, that might not be the case actually. So to answer your question, the general recommendation is to go for a mounting in horizontal line only. For a vertical line, then you need to have a cross confirmation from the vendor to confirm whether will there be any deterioration in terms of the performance of the meter if we are mounting on a vertical line. Okay, that was your question number 2. Question number 3, question number 3, can you just repeat? I forgot actually what you told. About the
Sir, about
repeatability.
the range, yes,
Repeatability, correct?
Yeah.
No, see, repeatability, I tell you, there are, it's a very good question you have asked. Generally, what you see is when you talk of repeatability, In today's instruments, the smart transmitters which we are getting, the accuracy covers, the combined effect of linearity, hysteresis, deadband, everything basically. All is combined together. Repeatability wise is generally never a issue with the transmitters. Repeatability wise becomes very important when you're talking of switches. Okay, when you are talking about the analyzers, but when you talk of the transmitters, repeatability is generally not looked into. I will not say not looked into, but generally is not that important parameter. It is basically the accuracy, which has a combined effect of linearity, hysteresis, this thing. Okay, repeatability generally becomes important, as I told you, in the switches, which are basically purely a mechanical item. Whether switch will actuate every time when the goes to that level. Okay, or basically in analyzers, repeatability is very very essential. In the transmitters, generally that is not a point of concern actually. But yes, you can look from the catalog and you can see in terms of repeatability. But as I told you, uh, vendors nowadays will say accuracy. When you talk of transmitter, you only talk of one word which is most important, is accuracy, which basically is a combo of linearity of the transmitter, hysteresis, and other effects put together. So all combined together. Any questions? Okay, moving on to the next, which has the same principle as an orifice plate because it is a differential pressure measuring principle, is a venturi. Now, if you see here venturi, you will see there are three parts. The inlet side, which is straight and then converging, then a flat portion in the middle, which is called a throat, and then the diverging portion. Okay, and you can see the tapping point on the throat, which is basically high pressure, and then a tapping point on the divergent section, which is LP. So like any other DP instrument, it is measuring a differential pressure between the 2 points, and which is giving you a flow. And similar to an orifice plate, the relation here also is a square root. It is not a linear relation. Okay. So now what are the advantages? The advantages here compared to an orifice plate is that venturi has a low pressure drop. Generally in an orifice plate, the pressure drop is very high. Now again, here the condition should be that the fluid or the liquid should be, okay, a very clean one. Okay, and the advantage here, again, one of the advantage here more is it is very easy to maintain, because if you see, these are just the pipe sections which are put together, convergent, throat, and divergent. So it is a very simple mechanical equipment, sort of, you can say that. Okay, with no moving parts and just the takeoff points, at the two ends. Now here, because of this size of venturi, okay, generally there are, if I remember correctly, generally 4-inch is on the lower side, and then you can go up to 24-inch and 28-inch venturies also. Okay, higher size. So that is one advantage, that you can also have higher size venturies if the application demands that. The limitation, as I have told you already, basically is a non-linear flow characteristics. It is basically a square root relation, like an orifice plate. Okay. Sometimes few things might get stuck up in the throat. Particularly, this happens if the venturi is of the smaller size, 4-inch and around that. And if the liquid is not clean, then something might get stuck up in the throat. Okay. And obviously, if the application is very corrosive, then this becomes unviable, because the metal you are going to use here is going to be very expensive, so which will make the cost of venturi very expensive. So that is one of the very disadvantages there actually. Okay, so for very corrosive applications, generally, because the corrosive applications require very exotic material which are suitable to meet that application. So, like example, monil, tantalum, hastelloy, which are very costly. So generally we don't use there because the cost is very exorbitant. Okay. So, and the quality and the reliability also, the accuracy is not very high. Okay, being a flow element mechanical device. Okay, and yeah, that's it. So generally these are used for very very common applications. Okay, these are not used for very specialized applications, water or even the normal gas flow rates. Okay, but obviously the fluid has to be clean. Any question on this? Okay, we move on to another type, swirl type flow meter. Now these type of flow meters are not very commonly used, but just to make you aware, okay, that this type of flow meter also exists. Okay, now as the name suggests, swirl means movement. Now if you see the red color arrows, the fluid goes the impeller and then they take the path as shown in these red circles. Okay, and then the fluid comes out. So there is an impeller on the inlet, and then the flow takes this profile of circular motion and then it goes out. So similar to like a turbine meter, basically, the flow velocity or the flow energy itself is used to move this impeller, and then the fluid slowly comes out after traversing the path which is shown here. So the advantage here is there are no moving parts. Like any other flow instrument, it does require a straight length, but it is a very short straight length they require upstream and downstream. You don't require a higher straight length like 10D or 20D. Okay. Again, it is suitable for measuring liquid, gas, and steam application. Somebody asked in the previous slide the repeatability. As I told you, that repeatability generally is more synonymous with the mechanical instruments or the mechanical mode of measurement. So if you see here, everything here is mechanical. There is nothing electronics about it. So here, yes, repeatability is the important issue, and yes, it has excellent repeatability. And the main advantage is it is unaffected by pressure, temperature, and density, similar to your vortex meters. The limitation is, yes, the pressure drop is there because if you see, there is a restriction. It is a convergent and then divergent. So anything which obstructs the flow will produce a pressure drop. So the limitation here is this produces a pressure drop. And again, as I told you, like vortex, it requires minimum flow, which is the minimum Reynolds number for it to measure the flow. Below that, it will not be able to measure. Now moving
Sir,
on to
Akesh, the man has got a
Sir.
question. He wants
yeah,
to
please.
Sir, can you please tell me one application area where we can use a swirl flow meter?
See, you can measure for any gas application. As I told you, here you can see liquid, gas, and this thing. Anything which is clean, anything which is for which you get a material suitable or compatible with that. As I told you, for example, water you can use, normal nitrogen you can use, okay, or any other gas, basically you can use. So even steam application, okay, you can use these meters as long as they are not contaminated or they are not dual phase. Dual phase means liquid should not be having any gas or gas should not be having any liquid entrapment. Preferably it should be a homogeneous fluid only. Liquid means pure liquid, gas means pure gas.
There is one more question for Nikhil also. Nikhil, you can ask your question.
Good morning, sir.
Yeah, but
I just note down its limitation, minimum Reynolds number required. How much minimum? Actually, can you please explain what should be the criteria of minimum Reynolds number? Because as I know, up to 2000, it would be tangent flow, and beyond the 5000, it will be turbulence.
see, the 2000 and 5000 basically are the definition which are given to define the flow profile. So you're right basically in that. So any Reynolds number which is up to 2000, the flow is considered to be laminar. Between 2 to 4000 is a transient phase, okay, partially laminar, partially turbulent, and above 4000, these are again the guidelines, okay. Above 4000, basically the flow is considered to be a turbulent flow. Now, to get the specific, these are again the guidelines. There is nothing like if I say for a swirl meter, let's say 2000 is the minimum. There is, you will not find it anywhere specifically written there. These are purely guidelines. So, to know exactly, it again depends on vendor to vendor, because suppose there are two vendors, vendor A and vendor B. Vendor A might say that okay, my meter can measure with a Reynolds number, let's say up to 2000, whereas vendor B can say my meter can measure Reynolds number up to 1500. So for that specific thing, you need to then see what the vendors can offer. Okay, those vendors who are marketing these swirl meters. But in terms of definitions, yes, you are right. Anything less than 2000 is laminar, above 4000 is turbulent actually. Okay. See, there is no specific thing. I cannot say that okay, it has to be this only, because it is vendor specific also, and these are purely guidelines. Okay. So you need to see when it says minimum Reynolds number, then which minimum they are talking about actually. So I did not give any figure because that figure then would have been vendor specific. So which would have given a false reading, because then you would have thought that okay, if this is the Reynolds number, then it will always be like that, which is not correct. That is the reason I did not put any figure in the minimum. I just told minimum Reynolds number.
Hope you have got your answer.
Yes, sir. Thank you.
Now moving on to the next one, oval gear. Now you see here in the picture, these are the gears which are in oval shape, and these both are mechanically linked to each other. There are two gears. Now the is a very simple phenomena. When the fluid comes in, these gears move in the opposite direction, and the liquid then passes on from the left to the right side actually. Okay, purely mechanical. Okay. Now if you look into this and we look what are the advantages these oval gear offer, accuracy is very high, because with each revolution of this oval gear, a specific volume is transferred from the left to the right side, or you can say from the inlet to the outlet section. Okay, suitable for measuring media with high viscosity. So in this case, you can also measure the fluid which are highly viscous, means thick. Another beauty is these are bidirectional flow meters. So the inlet can become outlet, the outlet can become inlet. So you can measure the flow in either direction. No profile effect, which means you don't require upstream and downstream straight length, which you generally require in any volumetric flow measurement instrument. So no requirement of any upstream and downstream straight length. Then no external power supply, because you can see yourself, these are purely a mechanical operated device with just oval gears two together, which are mechanically linked and which move when the fluid comes in actually. So by the virtue of the fluid velocity which impinges on this oval gear, they start rotating actually. So disadvantages, they can be used only for the liquid. You cannot use these for the gas applications. Another disadvantage is high pressure drop. So where you don't want your flow instrument to produce high pressure drop, then these instruments are not suitable. The third thing, conventionally, which is with any instrument, is if any instrument has a moving part, obviously it will lead to wear and tear in the course of the time. Accuracy decreases with the lower viscosities. So if the viscosities are lower, then the accuracy will decrease. Again, if the liquids are contaminated, so that contaminated liquid might get stuck on these oval gears, might get stick onto that, or might damage, the gear sharpness. So that is something which is again one of the disadvantages. It should be a pure liquid, okay, with no solid, because any solid which will come will then block the movement of these oval gear meters. So you have to ensure that the liquid is a pure liquid again, without any solid contamination. Any questions on this? Actually, it's a very simple, pure mechanical device.
Nikhil has a question actually. He wants to
Yep.
understand the totalizer part in the oval gear.
Sorry.
Nikhil wants to know how the totalizer works over here. Totalizer
Totalizer.
for
Okay.
oval gear.
Okay. See, every one rotation of this gear, okay, will confirm a particular quantity of the fluid, as I told you, which has come in from inlet and gone towards outlet. That means the fluid transfer. So one rotation of the gear means a fixed quantity of the liquid flown through. Clear, Nikhil? Hello.
Can you please repeat? Actually, my speaker doesn't work.
Okay, no problem. See, what I'm saying is one rotation of these gears, okay, will confirm a fixed quantity of the liquid being flown through. Okay. So, just to make the things very simple for you to understand, let's say with one rotation of this oval gear, 1 meter cube of liquid goes through with one rotation. Okay. So if there are 10 rotations, so how much flow has passed through?
10 meter cube.
10 meter cube. Simple. Okay. So that is totalization. So if you just measure the because what you do is you just measure the number of rotations in this, and then you simply multiply by the flow, you get totalized flow. Because with each rotation, a fixed quantity of flow passes by. Clear?
Clear, sir.
Okay.
Jasprit has a question on, basically he wants to know whether we can get a 4 to 20 milliampere signal output from here, or it's just a mechanical meter.
Inherently, this is a mechanical meter, but you definitely can get 420 milliampere. Okay, you need to then specify very clearly that with this oval gear you want an output of 420 milliampere. Like as I told you, in rotometer, for example, you see they are basically purely mechanical device, but then you do have the option whereby you can get a 420 milliampere output. So yes, you do have the option in case if you want. Either you can have just a local mechanical meter, okay, like the one you must have seen in the old age in the petrol pumps. The mechanical meters were there. Now you can see the LCD. So you can have that option also. Yes. No issue. Okay. So moving on to the next, lobed impeller meters. Now these are very much similar to what you just saw in the oval gear. So the picture itself will tell you how the things work. You see the fluid coming in the gray portion. You see the movement of these two lobed impellers going in the opposite direction. The arrows you can see, the up one going in the upper direction and the lower one going in the anti-clockwise direction. and then the third phase where the liquid gets entrapped, and then the fourth where the liquid starts coming out on the outlet side. So these four pictures show you the simple operation of how the liquid gets entrapped, the movement of the impeller, and then the liquid flows out. Okay. Now, if you look at the advantages, excellent measuring accuracy for gas measurement. So if there is any gas measurement, these are used basically. These are preferred compared to the other meters actually, which we just talked about, the previous one, for example, which are not suitable for the gas. So for this particular thing, you can use for gas application. Again, these don't require any inlet and outlet. So you don't require any state length, either upstream or downstream. And again, the third thing, no external power supply. Like any mechanical meter, it is driven by the fluid velocity itself. So it doesn't require any external power supply to move it. Similar disadvantages, you can use only for gas applications. For example, you cannot use for steam or liquid. Moving parts, again, will lead to wear and tear. Again, if any solid particle is there, it will then block the impeller movement. The process should not have a very high fluctuation, okay, a high differential pressure. It should not have a too high velocity because it will start causing the vibration of the impellers, okay. So these are generally some of the disadvantages or the limitations associated with the lobed impellers.
Arun wants to know about the pressure drop in this meter.
Pressure drop in these meters are high. Okay. Now, as I said, again, there is no definition of high or low because you have to see it. The pressure drop will vary on your process conditions. Okay, which obviously will be different in different for different process plants, and again different line size, process media, upstream pressure, temperature, density, viscosity. So yes, but to give you an answer in generic, these are considered as high. These are like high pressure drop meters. See, you remember one thing, guys. Anything which is an obstruction in the line basically is bound to have some sort of pressure drop. Okay. It's very simple as that. Just keep that in mind. Now, this is not a very commonly used in the industries, but these are like for flow measurement in the canals or ponds or the lake. Okay, these are called as the weir meters. So what happens here is an obstruction in the form of weir, which can be of rectangular shape or a V shape is there. And if you see the picture on the top, so this black one vertical is a weir. So the flow rate, if the flow rate is high, what will do is the head which is created above the weir, the dark blue color, the height will be more. So the higher the flow rate, the height of this head will be more actually. Okay. So, and this is the formula of measuring the flow rate. Okay. This is an empirical formula which is used for measuring the flow rate. Now, and these are the, definitions. For example, the measurement should take place 3 to 4 times the height. The minimum height of the crest should be 2 to 3 times the height. Okay. And then these are some definitions which are given. I mean, the nomenclatures. This is the crest where the liquid just starts falling below. This is called as the crest area. Okay. Now, what is the advantage of this? It is a very simple design because you are just putting a simple obstruction in the canal or just that obstruction. So what that obstruction does is it raises the level of the height of the liquid column. Okay. Now, if the flow rate is high, the head will be high. The height of this head will be high actually. So this is used for open channel measurement. Generally, whichever instruments you have talked about, basically we have talked about in the pipe, okay, in the closed pipe. But this is an instrument which is used in an open channel actually. Construction cost is very less. Now, what are the disadvantages? It should not have any solid contaminant which will block the wear. That is number one. Number two, you should not have any buildup on the wear. Means slowly, the upstream of the wear should not have any solid contaminant, So that because that solid contaminant will then give a false reading, because then the liquid head will show a different level which will not be based on the flow. Okay. So to make things simple, the liquid should be again as pure as possible without any contamination. There should not be any deposit buildup with the time. Deposit can be a sand deposit, can be a mud deposit, can be a solid deposit. That should not happen actually, because if that happens, then the reading will not be correct. It will be an erroneous reading. Okay. So these are generally used, as I told you, in an open canal, or where you just want to see how much the flow rate is there actually, using the formula which is there. So this was the last slide of our today's presentation. Any question on any of the slides?
What Jaspreet wants to know, what is this L in the total formula, basically, for the wear meter?
See, the L is the length and H is the height. The height of the wear is H, and the length of the, for example, in the picture you see here, okay. So this from one corner to the other corner is the length, and the height is the height of the wear.
It's the cross section of the area that we are actually
Correct.
calculating.
You're right. Absolutely. Yes.
Okay, fine. Jaspreet, I think you have got the answer for this. Although there is a document available, we can share that also with you so that you can actually do the wear meter calculations. It's a purely mechanical design. Normally, old times it was the civil engineers who used to do it, and they always had mechanical marking. If you go to some canal area, you will see on the canals they already have some level measurements over there. So they have marked it with paints. So as soon as the level goes up for these canals, they actually note that this much of the water is actually going through. Even today also, a lot of areas are still not having any kind of online measurement. So they do the measurement primarily based on mechanical measurements only. So that is the way it has been being done. And I hope you had a good understanding of these flow meters. Any specific questions you want to ask? Any query or any questions we have missed to answer? And I hope all the people who have actually joined actually have marked their attendance also at the time of registration itself, so that we can actually know how many people are joining and who are doing it. And there is one more announcement, because you will be having a recording of the previous sessions also. That is not a problem. So there is a method to get that, because if you have missed the old session, so what you can do is you can actually request in the email and we will send it to you. Plus, we also have a YouTube channel we are putting over there. One thing new that we are going to do is we have our own channel for communication with all of our people who are actually in this training program. I'm just putting that link actually into the chat box. I request that all of you to please go to that link. It will be opening one small app where you can actually download it on your mobile in case you want to download, or you can access this through your laptop also. So it's an open messenger, like a WhatsApp is there, but we want to keep you away from WhatsApp and other distractions, just to keep it specific to the training program. Here we will be putting all of our announcements, any kind of the new developments or new changes which are coming up. plus automatically the recording goes into the same channel. So whatever the recording that we have done today, this will automatically be posted there once the meeting is over within next 10 to 15 minutes automatically. So you have the access to all the history, all the channels that we have actually interacted. Plus you can ask any questions, the team will be there to answer you. So I hope in case you have any challenges in joining this kind of application, let me know. And we are looking forward feedback from you for any kind of the new things that you want to learn. Okay. Any questions, or we can wind it up for the day now? Thanks, Jaspreet. This is what we are trying. We are trying to share the experience that we have with most of the people who can understand, because what we have found is the industry's need is basically not being met by the colleges, and the colleges are trying to build good engineers, but unfortunately the gap between the formal education and the need of the industry is totally very big. So we thought, why not to try to bring a change and let the young engineering boys and girls understand what is instrumentation and automation, and they are more confident in the field. That is our whole initiative that we are trying to do. Yeah, Arun, we can have a machine learning and IoT part also. That is also on the agenda, because we do have a training session planned for that, because that isn't. But we thought that let's start with the basics of instrumentation first, because as soon as you move into the software, it's a totally a different field. So our focus is primarily to start with the field first, field instrumentation, because you will see, you will find a lot of people learning software, but very few people actually understanding what is the field instrumentation, what is the hardware. So our initiative is to start with the field first. So you should understand what is happening in the field, how you install the instrument, how to select the instrument, how you maintain the instruments. And from there, we are going to take it this to the control panel, where you can actually measure how you are putting into some kind of a PLC, some data logger, then going into a SCADA, and SCADA logging over there. Then we are going to move it to for IoT and machine learning also. So everything is planned over there. But because of the paucity of the time, we have only one session in a week. We are looking for a feedback. If you people can give us a feedback to have 2 sessions in a week, we can have 2 sessions also. Currently, there are very few people joining, like almost 20 people maximum join in a session. So we are looking at just one session. But yes, as the more people join and we have got more traction coming up, we'll be having 2 or 3 sessions also working, where you can actually learn it in a faster way. My request is that please send our message to all of your friends, all of your colleges, all of your juniors, seniors, whosoever know. Please join our sessions, because this is something that we are trying to do for you, and more people who learn this will be benefited on this. Okay. Thank you very much for everyone for joining our session, and I thank you for everything that we have today. And it was an interactive session. Thank you very much.
Thank you.
Bye-bye.
Thank you.
Thank you, Manmeet ji. Bye.
Okay, bye-bye.